In this example, I want to work on page 197, number 67. It's a little more complicated, or at least it looks a little more complicated. It has negative exponents on top of negative exponents outside of parentheses. So there are one or two extra steps, but nothing that we can't handle. When you see a problem like this, the first thing you want to do is get rid of the exponent that's on the outside of the parentheses. And you basically just distribute that exponent into each and every term that's inside. You do that with all of them. I'm just showing you that it's got to go to everything. Once you do that, you're going to get a new look to your problem. You're going to have -2 to the -3rd exponent. Remember, we're not multiplying -3 times 2. We're multiplying the -3 times the 1 that the 2 has as an exponent. And again, the x also has an exponent of 1. And we're multiplying 1 times -3, so we're going to have x to the -3. And we're going to have y to the -3 times the -3, which changes it to a +9. Now let's distribute the -1 through to everything down here. We have x to the 1 times -1 gives me x to the -1, and we have y to the -1 times -1, which gives me y to the +1. Now, I know in your textbook they told you something completely different to do with this problem. It's just two different techniques to do the same thing. It's all in what you find to be the clearest, what makes the most sense to you, and what seems the easiest for you to work with. If this way doesn't make sense to you and you like the way in the book, then do what's in the book. I believe the book would have told you to swap these two and put this whole thing on the bottom, put this whole thing on the top, and change these exponents and then distribute them. I find it easier to just distribute first and deal with everything one thing at a time. Now, we're back to those steps where I told you about relocating everyone. Everyone's going to do some moving based on the type of exponent they have. So let's start with my first term here, -2 to the -3. Now, some people get confused over this negative sign right here. That one has nothing to do with our moving. It's just going to stay with the 2. We're focusing on this one. That -3 is the reason that this 2 has got to move. So -2 drops down to the bottom and gets a positive exponent. Let's look at our x. X to the -3. It needs to drop down to the bottom as well and get a positive exponent. How about this x? It's got to jump to the top and get a positive exponent. Now, it won't always be the case, as it's been in the last two examples, that we swap places. If only one of them has a negative exponent, then that's the only one you move. It just so happens that both of our x's have negative exponents, so they actually end up swapping places. They may end up joining each other and needing to be combined. I'll do another example that has exponents like that so that you can see what I'm talking about. For the y's, they both have positive exponents, so they're both just going to stay where they are. They don't have to move. Now, let's go ahead and evaluate. -2 cubed is a -8. X to the 1 and x to the 3. I have 1x up here. I have 3 x's down here. So this 1x is going to cancel one of them down here, and I'm going to be left with x squared, 2 x's, down in the bottom. This 1y is going to cancel one of these y's, and I'm going to have 8 of them left. And they're going to be on the top, because that's where I had the most to begin with. And you're done. That problem went by pretty fast. They're very simple if you just think of them as moving from top to bottom, and simplify your exponents first before you start moving everything around. I think they go much faster.